I am going to solve a worded problem, a mixture problem to be specific. This is actually a request from one of my students because this problem came out in their quiz, ME and CPE quiz. Okay, so let's start. A large tank contains 500 liters of brine in which 5 kilograms of salt is dissolved. Brine containing 900 grams of salt per liter runs into the tank at the rate of 5 liters per minute. The mixture, kept uniform by stirring, runs out of the tank at the rate of 10 liters per minute. Find the amount of salt in the tank after 15 minutes. Okay, so what we're going to do is to write the given first. Now we have here 500 liters of brine inside the tank. So that is the volume of the solution inside the tank, 500 liters. It says that the solution is or contains 5 kilograms of salt. So it means that initially at time is equal to 0. Okay, so we let x be the amount of salt. So x is equal to 5 kilograms. So this 5 kilograms of salt is dissolved inside the tank initially. Now brine containing 900 grams of salt per liter, okay, gram per liter is the unit of concentration. So it says that there's a solution flowing into the tank. Okay, so we have concentration in, represented by C sub I. So 0.9, since we have your kilogram unit, so we convert grams into kilograms. So 900 grams is 0.9. So we have 0.9 kilogram per liter as the concentration in, or C sub I, flowing into the tank, with a flow rate represented by R. Okay, R sub I is the flow rate in. So the concentration of the solution, 0.9 kilogram per liter, okay, with a flow rate of 5. Okay, let me just get another pen. Okay, 5 liters per minute. So we should always check our units. Should be consistent, kilogram, kilogram, liter, liter. Now, it says that the mixture runs out of the tank at the rate of 10 liters per minute. Okay, so we should have a concentration out and a flow rate out. So actually, the flow rates are different. Flow rate in is 5 liters per minute and flow rate out is 10 liters per minute. So as you can see, the solution inside the tank runs out a little bit faster, okay, compared to the solution flowing into the tank. So it means that the volume into the tank will be affected or will decrease. That's why the concentration out is represented by, of course, we don't know the amount flowing out into the tank, so X over, remember that concentration is equal to the amount over volume, and flow rate is equal to volume over time. Now, this volume here, of course, the concentration out. So we have the volume 500 liters, it will decrease actually. So 500, so knowing that, okay, the volume that we're going to divide this concentration out is, of course, 500, and then we add, of course, the difference of the flow rate times time. So we have R sub I minus R sub O times times. As you can see, R sub I is 5 and R sub O is 10. Now we have the new volume to be divided here. 500, this is minus 5 times T. So this is now X over 500 minus 5T. And of course, the unit is in kilogram per liter. Okay, let me erase this one. Now we are asked to solve for the amount of the salt in the tank after, what's the time here? 15 minutes. Okay, so of course we should write what is required. So it's the amount. So x after 15 minutes. Okay, now we write the solution. Okay, in mixing problems or mixture, the rate of change is equal to the difference of the rate in minus rate out. So we have this equation dx over dt as the rate of change equal to rate in, or the amount of or the substance entering. So we have rate in minus rate out. Okay, which is equivalent to rate in is the product of concentration in times the flow rate in. Rate out is concentration out times the flow rate out. Okay, so we are going to plug in these values here. So dx over dt is equal to 0.9. We don't need to write the units because we have already made sure that the units are consistent. So 0.9 times 5 minus the concentration out, this expression here. So x over 500 minus 5t times the flow rate out, which is 10. Now we are going to arrange this equation. This is a differential equation, first order dE and linear in x. As you can see, if you transpose this term to the left-hand side, so we have dx over dt equal, or we transpose this part. Okay, so that's plus. This will become 10x over 500 minus 5t. Actually, we can simplify this one. So if we factor out 5, this becomes 100 minus t, right? So 10 divided by 5 is 2. So this becomes, let me erase. Okay, that's 2x. Okay, remember, we simplified that part here. So that's 2x over 100 minus t equal to, we multiply this 1.9 times 5, this is 4.5. This is a linear equation, first order linear equation. Okay, linear in x. Now we erase this part so we can have a space for solution. Now that we have arranged the linear equation in standard form, now we solve this equation. So remember that in solving the linear equation, so we should put the equation into standard form, and then by that we can see our p as a function of t here, which is 2 over 100 minus t, and our q as a function of t equal to 4.5. So you will know this if you have encountered or solving, or if you tried to solve linear equations. Now, in solving linear equations, so we need to determine the integrating factors. So that's e raised to the integral. In this case, our independent variable is t. So this is p of t dt. So this is equal to e raised to the integral of, our p as a function of t is 2 over 100 minus t times dt. Okay, so we integrate this part. This is actually logarithmic. So we check. So differentiate this. It will be negative dt. So we have a neutralizing factor here. So this will be what? E raised to negative 2 ln of 100 minus t. And then we simplify e raised to ln of 100 minus t raised to negative 2. Okay, now e raised to ln of something is equal to that something. Okay, so I, or the integrating factor, is equal to 100 minus t raised to negative 2, or this is equal to 1 over 100 minus t squared, okay, to make the exponent positive. Let me erase this part first. Now, since we have the integrating factor, we multiply this integrating factor to the standard form of the equation, and it should be noted that, okay, once we multiply this standard form by an integrating factor, the equation will become an exact. And the left member is always equal to the product of the integrating factor, okay, which is this one. So 1 over 100 minus t squared times the dependent variable. In this case, x is the dependent variable, equal to the right-hand side, which is q as a function of t. This is 4.5 times the integrating factor, which is 1 over 100 minus t, okay, squared, times dt. Of course, we integrate this one. Now we erase this part. Okay, so we integrate the right-hand side of the equation. So this will become, of course, we put the constant at, before the integral symbol. So 4.5 integral of, we bring this up, this becomes 100 minus t. It's actually power formula, so negative 2 dt. Now, to satisfy the power formula, so this should be negative, right? And then neutralize outside, so you put negative here. Okay, do you follow? I hope so. So you put negative, so negative dt. We can utilize the power formula. So this will become okay, negative 4.5, 100 minus t raised to, this is n plus 1, so negative 2 plus 1 is negative 1. This is negative 1 over negative 1, okay, plus c. So then you copy the left-hand side, which is, okay, 1 or x over 100 minus t squared. Okay, this is, okay, we should arrange this one. Okay. What's next? We simplify, or we remove the negative. Negative over negative is positive. This becomes what? And then we multiply the entire equation by, okay, let's write first. So x over 100 minus t squared equal to, so this becomes positive, and then bring this down. So we have 4.5 over 100 minus t plus c, and then we multiply the entire equation by, okay, to solve for x, of course, so 100 minus t squared. So we have now x equal to, so this becomes 4.5 times, of course, we still have 100 minus t in the first term, plus c times 100 minus t, of course, squared. This is our general solution. Now, we need to determine the expression first. So we find for the value of the arbitrary constant c. So we utilize the initial condition. So we plug in 5 here. equals 4.5 times 100 minus the time is 0 initially. So that's 100 minus 0. So you have C times 100 minus 0 squared. Okay, so we solve for C using our calculator. So 4.5 times 100, and that is 450 transpose. This will become negative 450. Negative 450 plus 5 is negative 445. Okay, and then 445. Okay, let me use my calculator. Divided by 100 squared, so that is... Okay, so we have negative 0.0445. Okay, so now we rewrite our solution. The expression will be the amount of salt at any time t. So x is equal to 4.5 times 100 minus t. Okay, we have C, which is negative 0.0445 times 100 minus t squared. Now we are asked to solve for the amount of salt after 15 minutes, so inside the tank. So at time is equal to 15, so we now plug in the value of t here, so 4.5 times 100 minus 15 minus 0.0445 times 100 minus 15 squared. So we have x equal to, let's use our calculator. Okay, wait for a moment. 100 minus 15, so times 4.5. We have, so in the first term, you can actually use a calculator directly, but I'm using this in a very old calculator. So bear with me. 382.5 is the first term, and here we have 100 minus 15 squared. Okay, times 0.0445. So we have 321.5125. Okay, therefore the value of x is 382.5 minus the second term. We have 60.99 kilograms. Okay, so that's it. That's the solution for this problem, and this is the final answer, 60.99 kilograms. If you have any questions, to my students especially, so kindly message me via MS Teams or our group messenger. Thank you.